So page 43 to 44, we're continuing with the carpentry. We're going to do some things that may appear kind of silly, but it does help you to better understand as a carpenter how to measure and be able to take half of certain lengths and that kind of thing. So let's look at this. Top of the page, Kristen Leonard is a carpenter. In her work, she must be able to make careful measurements. Often, she needs to use fractions and mixed numbers. Okay, so underneath the picture of Kristen, we've got a board that's 9 feet long. Okay, so let me draw a board here. I'm not a real good artist, but I can draw something as simple as a board, I think. Okay, so this board is 9 feet long from here to here. All right, so it's cut into sections of the given length. How many sections are there? So first thing we're doing is she's cutting this board into sections 3/4 feet long. So 3/4 of 1 foot, or how many inches are in a foot? 12. So 3/4 of 12 inches would give me well, it would tell me how long each of these sections are. So if I take these of and multiply it, remember when you multiply fractions, if you've got a whole number, you put it over 1, you multiply the top numbers over the bottom numbers, and that reduces to 9 inches. So 3/4 of a foot is actually 9 inches. All right, so when we're comparing, we always want to compare in the same measurement. So I'm going to erase what I've got here. We'll remember that 9 inches is 3/4 of a foot. So we need to divide this 9-foot section into 9-inch pieces. Well, if we divide 9 feet, or if we change 9 feet into inches, that would really help. So 9 feet times 12 inches is 108 inches. So it's 108 inches long, and we're going to cut those into 9-inch sections. So we've got 108. We're going to divide it into 9-inch segments. So 9 goes into 108. We get 12 9-inch segments if we were to go and cut this up into lengths there. So that's how you would do that. Get rid of all my... you may find another way to do it that you like better, but that is one way of doing that. So the next one says sections 1.5 foot long. Exactly the same. We're going to have to change 1.5 feet to inches. So 1 1/2 feet. So 1 foot is 12 inches. What is a half a foot? 6 inches. So that would be 18 inches. 1.5 feet is 18 inches. And again, this is 108. We're going to divide 18 into 108 and find out how many sections there are. If it does not go into it evenly, let's say that when I divide 18 into 108, I get 6.3. Well, how many 18-inch segments can I get out of that? 6. I'm going to have this extra, and that's waste. But I am going to get 6 18 inches. I don't care about the rest of it. So that's what they're doing there. Let's continue on. If we have, the next one says if we've got this board, let me see if I can erase some of this without erasing my whole board. If I've got a board 7.5 feet long, need to connect my board back together, 7.5 feet long, and I want to cut it into equal parts. So let's say I've got 7.5 feet. I want to cut it into, number 4 says 6 equal parts. Okay, so again, I'm going to change this into inches. So 7 feet would be 7 times 12 inches, so that would be 84 inches. And then this 1/2 of a foot is 6 inches. So I'm going to have a board 90 inches long. That's 7.5 feet. If I want to cut that into 6 equal parts, I'm going to take that 90 inches and divide it by 6. So 6 goes into that. So I'm going to have 6 equal parts that are 15 inches each. And I do that for 5 and 6. Okay. And kind of do the exact same thing with 7 and 8. And then we get over to 9 through 14. Write the measurement using a fraction or a mixed number. Okay, so for instance, we have number 13. I guess we don't really need all of this. Number 13, it says we've got something that's 6.667 feet. Now, when you're measuring boards and doing construction, you very, very rarely are going to use decimals. You're going to take a tape measure, and things are going to be done in fractions or mixed numbers. Now, a fraction is like 3/4. A mixed number is like 3/4, but it has a bigger number out here, 6 3/4. So if it's 6 3/4 inches, you're going to go 6 inches and then measure another 3/4. Whereas this is just 3/4 of an inch. It's not even an inch long. So mixed number, fraction. All right, so if we have 6.667 feet, for the most part, this is 6, and then 667 over 1,000. Okay, this decimal means that everything to the right, we count 1, 2, 3, and that's how many zeros go underneath that 667. And then we take this fraction and we reduce it. And when we reduce it, we get 2/3-ish. Not exactly, but pretty close to it. And that would be the decimal 0.667 written as a fraction or as a mixed number. And one of the things you'll notice too when it comes to construction, you aren't going to be getting measurements like 6 2/3. All of your measurements are going to be factors of, well, usually 16, because when you've got a tape measure and you've got 1 inch here and 2 inches here, well, here's a 1/2 inch, and if it's broken into fourths, it would be each of these is 1/4 of an inch, and then we break those into smaller units, and if you count from here to here, we have 1, 2, 3, 4, 5, 6, 7, 8. So if we're measuring something 1 5/8, we would go 1 and 1, 2, 3, 4, 5, and that's where we would measure to. So 5 of these 8s. If we go one more size smaller, take half of all of these are called 16ths. So if we are measuring, for instance, 1 7/16, we are measuring on our tape measure 1, and then 1, 2, 3, 4, 5, 6, 7. So it's one little mark shorter than a 1/2. This is a 1/2. So it'd be one mark shorter. So we're going to use, in dealing with measurements, we're going to use a 1/2. We're going to use fourths. We're going to use 8ths and 16ths. Once in a while, you'll double 16 and get 32 and measure in 30 seconds, but not very often. Usually when you're doing construction, the smallest you're going to go is 16ths, but even that's kind of small. A lot of times it just goes to an 8. So when you're measuring, building a wall or something, you may measure that the distance between two studs is going to be 1 7/8 or something, and so then you're going to be 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So you're going to be at the 8th mark. Did I measure that right? 1, 2, 3, 4, 5, 6, 7. Yeah, here's 7/8. Because this is 16th, this is the 8th, this is the quarter, 1, 2, 3, 4, and this is the half, 1/2. Okay, we cut it in half there. So that's just some interesting stuff there about carpentry. Another thing that I want to go over just real quick on 15 is it's talking about a 2x4. Now, when you're building inside walls, usually you're using a 2x4. Outside walls, you're usually using a 2x6. And one of the things that people often don't understand is that a 2x4 is not actually 2 inches by 4 inches. So 4 inches, 2 inches, and when you show the top of a board in a drawing, you put an X there to show that you're looking down on it. So a 2x4 is not actually a 2 inch by 4 inch. That's what it would be when it's a cut in its rough stage. And then what they do is they cut it down smaller than that, and it ends up being, well, the book says 1 5/8 instead of 2, and 3 5/8 instead of 4. But most of us, when we're building, we don't do the 5/8, we do 1.5, and instead of 3 5/8, we do 3 1/2. So it's a 1.5 by 3.5 piece of wood at various lengths. So anyway, Kristen stacks 4 of these boards as shown here. What is the total height of the stack? That's a totally worthless story problem because you never care what the height of the stack is when you stack those boards. But there are times where you have 3 boards stacked up like this, and you may want to know, and I'm doing this all for a reason, you may want to know the distance between here and here and here and here. Well, if each one of these boards is 1.5, you've got 1 1/2 times 3, and that will give you this length here that you're looking for. Okay, and this is very similar to how you're framing out a window. Sometimes you only have one board here, and then this here to put this plate on. But sometimes you would use 2x4s here. I guess you'd use 2x6s because this would be on an outside wall. But anyway, you sometimes might want to know how thick that is with all 3 of those stacked together. So that's a good reason to learn what they're doing in number 15. So anyway, that is the practice section, the problem-solving applications on pages 43 and 44.